Hello, dear students. I prepared some exercises about stoichiometry because I know that this is a little difficult for you. Let's begin one by one, and then you will take note of the ones uh, that you still have problems that you don't understand, and you can send me an email telling me what do you need exactly. Well, here is the first one. The first one is a conversion from grams to moles. For example, we begin from 20 point grams of calcium. As you can see, this number has two significant figures and is the given number. And you want to convert this into moles. Then what do you have to do? Well, you know that 40.08 grams of calcium is 1 mole of calcium. Where does this number come from? Oh, you go to the periodic table, you find the element calcium, and you can see that the molar mass, or the atomic mass in this case, because it's an atom, is 40.08 grams, 1 mole. So you can cancel grams of calcium or with grams of calcium, and at the end you have the result of the operation is in moles of calcium. That is what you are needing in this case. Well, you multiply 20 by 1 and divide by 40.08, and the answer is this number. But as uh, you begin from two significant figures, you have to report two significant figures. So you round up this number, and the final result is 0.50 grams of calcium. Let's go now to the following exercise. In this case, it's the opposite. So going from moles to grams. The number that is given is in moles. So you say, well, 3.5 moles of carbon, and you know that 1 mole of carbon is 12.01, according with the periodic table. Then you cancel mole with mole, and the answer will be in grams of calcium, of carbon, sorry. In this case, the answer is 42 grams of carbon. Two significant figures because the given number has two significant figures. In the third case, well, we are using the mole ratio between two substances in a chemical reaction. Remember that in a chemical reaction, you have the reactants to the left and the products to the right. The numbers that you have in front are the number of moles of every substance. Then, in order to go from moles of X to moles of Y, you have to use the mole ratio as conversion factor. Let's see one example. For example, in this case, you need to go from uh, grams to number of particles. In this case, in the first part, it's the same operation we have already done, but in order to go from mole to particles, in this case atoms, then you have to multiply by the Avogadro's number. Remember that 1 mole of any substance has 6.02 times 10 to the 23 molecules. Then you say 15.0 grams of water. If you know that 18.02 grams of water is 1 mole, and you know that 1 mole of water is this number of molecules, then you can find out the number of molecules of water in this amount, in this mass of water. Using the calculator, you can go from 15.0 to multiply by the Avogadro's number and divide by the atomic mass of the molecule of water that you can calculate this way. The mole ratio, as I told you, for example, is you want to know uh, the ratio between hydrogen molecules to hydrogen oxygen molecule. Well, it's 2 of hydrogen per 1 of oxygen, and it will produce 2 molecules of water. Then the ratio is 2 to 1, 1 to 2. Let's see this in a problem. How many moles of water are produced when 5 moles of oxygen are used? Well, you know, the given number is 5.00 moles of oxygen, and then you say, well, 1 mole of oxygen here in the reaction produces 2 moles of water. Then the ratio is 1 mole of oxygen to 2 moles of water. You cancel mole of oxygen with mole of oxygen. You multiply 5 by 2, and the answer is this number. Look, 3 significant figures because the given number has 3 significant figures. Now we are going to have a problem that goes from mass of aluminum to mass of aluminum oxide. That is the product of this reaction. Well, you say the given number is 6.550 grams of aluminum. Then you multiply by the atomic mass of aluminum. This is from the periodic table. And you can see that 26.98 grams is 1 mole of aluminum. Then you go to the moles in the chemical reaction, and you can see that 4 moles of aluminum produce 2 moles of aluminum oxide, according with the coefficients in the chemical reaction. But after that, you have to multiply by the mass of 1 mole of aluminum oxide. That is 101.96 grams. When you multiply and you divide by this product, you get the mass of aluminum oxide. Remember, you multiply this by this by this by this, and you get a number, and then this by this by this, and you get another number. Then you divide, for example, y by x, and then it's that you get this number that will be in grams of aluminum oxide as you are asked for. Well, if you still have any question, you can ask me. But try to watch the video again, stop it at any time, and you will see that you will understand. If you copy this from here to your notebook, it will help you a lot. Okay, see you soon.